factoring x squared plus bx plus c variants. So some trinomials don't look like x squared plus bx plus c, but they actually are. They're just in disguise. So for example, and we've actually seen this one before, some might have a greatest common factor that's hiding that pattern. So looking at this example, is there a greatest common factor? Well, we could divide each term by x, and we could also divide each term by y squared. So if I do that, and pull that GCF off each of those terms, I'd be left with xy squared times y squared minus 9y minus 10. And now you can see that this is a regular factorable x squared plus bx plus c trinomial. So minus 10, two numbers that multiply to minus 10, add to negative 9. Well, that would be, let's try 10 and 1, and I could use negative 10 and positive 1. So this would be equal to xy squared times y minus 10 times y plus 1. So you can see we managed to factor this thing that did not look like an an x squared plus bx plus c trinomial, but by taking out the GCF we could do it. So sometimes trinomials will have more than one variable, but there's no greatest common factor. But these are still factorable using the same method. It's just that we're going to have two variables in our factored answer. And so I'm just going to show you this example, and then I'll FOIL it to prove to you that what we did worked. So for now, basically what we're going to do is ignore the b's, and just imagine this was a squared minus a minus 12. That would mean I need two numbers that multiply to negative 12 and add to negative 1. If you don't see a number in front of that middle term, or in front of any term, it means there's a 1 there. So numbers that multiply to 12 and could combine to 1, well, 4 and 3 might work for that. And if I do negative 4 plus 3, perfect. I should be ready to go. So in my brackets, I'm going to have a minus 4, but instead of ending there, it's going to be minus 4b. And in the second bracket, I'm going to have a plus 3b. And doing this is what gets me the b in the middle term and the b squared on that final term. And I'll FOIL it out just to prove it. So let's check. I'd get first a squared outside terms plus 3ab, inside terms minus 4ab, and last terms minus 12b squared. That simplifies to a minus ab minus 12b squared. So you can actually see that that having that sort of a squared ab b squared, all it changes is that I have to have that second variable in the second term in each binomial. And that's how we get the AB combo in the middle and the B squared at the end. Some trinomials might follow the pattern, but have a higher power than x squared. And these can be factored with a technique called substitution, which is a very important skill in higher levels of math, especially when you get into learning about calculus. So this trinomial, if we think about it, x to the power of 4 is really x squared squared. And then we have minus 9x squared plus 18. Well, if we were to substitute the letter a for x squared, what we would have is a squared. So I'm putting a in the place of x squared in the brackets, and then I still have that squared, minus 9, and then I replace x squared again with a, plus 18. And what we can see is that this trinomial, even though it had a power of x to the 4 instead of x squared, it is still following the trinomial pattern, and I can factor this the same way. So I find numbers that multiply to positive 18 and add to negative 9. That would be negative 6 and negative 3. So this would factor to a minus 6 times a minus 3. But my original question did not have a in it, it had x in it. So then I have to substitute that back in, and so really this is x squared minus 6 times x squared minus 3. The last variant on these expressions I want to show you is that we can have an expression in the place of x squared instead of that plain variable. But we can also solve these with substitution. If you look at this problem, it looks a lot like what we've seen, only x plus 4 we're going to make equal to a, and when we substitute that, we get an expression that looks a lot more like what we've been solving. Whoops, sorry. That's 2a squared because we had x plus 4 squared. And now this looks like something we might be able to solve because it has a greatest common factor. So I factor out 2 and I'm left with a squared minus 6a plus 5. And now I'm going to get to finding factors of 5 that add to negative 6. So that would be negative 5 and negative 1 multiplied to positive 5 and add to negative 6. So that's going to be 2 times a minus 5 and a minus 1. And then again, I don't want a in my final answer, I want x's. So I have to substitute back in x plus 4, and that gives me 2 times x plus 4 minus 5 and x plus 4 minus 1. But of course, if I can simplify, I should simplify. So that's 2 times minus 4 minus 5 is x minus 1, and plus 4 minus 1 is x plus 3. And so I took this expression that looked a little bit different, but I was able to factor it into something actually pretty simple.